We're looking back today at regular polygons, and we're thinking about perimeter and area of regular polygons. Now, a lot of what we do here in this lesson is going to refer back to Investigation 3. It's going to refer back to what a regular polygon actually is. It's also going to refer back to what we know about special right triangles. So if any of those things, it doesn't make sense to you, you should probably go back and rewatch those videos to catch up. So here, a few facts, all right? Now, we're looking at regular polygons today. That's all we're looking at. In a regular polygon, there's a point that we consider the center where we have the same distance out to every vertex, and a central angle would be the angle that is created when we connect those two the segments from the center to two consecutive vertices. All the central angles would of course be congruent because all of our side lengths are congruent in our polygon. Well, an apothem is the line from the center of our polygon that connects to our side at a perpendicular intersection. It is the line perpendicular from the side of our polygon to the center. The perpendicular distance from the center of a regular polygon to its side is the apothem. So it is a distance. Let's take a look at perimeter. Find the perimeter of the polygon. Well, it's a 1, 2, 3, 4, 5, 6-sided polygon. One side is 3 feet, so of course this is 18 feet. Here, this polygon is 1, 2, 3, 4, 5. All right, started here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-sided. One side's 2.7 centimeters, so this is going to be a 27-centimeter perimeter. All right, perimeter, regular polygon, super simple because all the side lengths are the same. Now, talking about the area of a regular polygon. Now, for regular polygons, here's one way that we can find the area of any regular polygon, and the area is going to be 1/2 the apothem times the perimeter. Okay? Notice how in a regular polygon, it's basically formed by several congruent triangles. So when in doubt, if you couldn't remember this, if you can find the area of that triangle right there, you can multiply that area times 1, 2, 3, 4, 5, 6, 7, 8. Times 8, because this is an octagon, you can multiply that area times 8 to get the area of the full figure. But we can also use this formula right here. Sometimes just finding the area of that triangle and multiplying it times 8 might be the easiest way. Sometimes knowing the area is 1/2 the apothem times the perimeter. Also very, very helpful. So it says find the area of the regular octagon with an apothem about 18 inches. So notice here we're given an apothem length of 18 inches. We know the area of a regular polygon is 1/2 the apothem times the perimeter. So that would be 1/2 times 18 times our perimeter. Well, if one side is 15 and this is an octagon, the perimeter must be 120. And so we plug that in. This is the area of our octagon. Okay, here it says use the apothem and the perimeter to find the area of the regular hexagon. So notice here, all they gave us was one side length. Okay, so it really all comes down to this triangle right here. That's what we need to focus on. So I'm going to draw this triangle for it. Of course, we know it's isosceles, and if we draw a perpendicular segment from the vertex angle of an isosceles triangle to the base, we know it's going to bisect the base. That is something that we've said for a while now. Now notice that the one piece of this that I need is the apothem, because I know I'm just going to do the area being 1/2 the apothem times the perimeter, and I can find the perimeter right now. I know the perimeter, since it's a hexagon, 10 times 6, it must be 60. So the only thing I'm missing is the length of my apothem. And so that's really what I'm trying to find right there. I'm trying to find the height of this triangle. And if the whole length across the bottom is 10, it must be 5 and 5 when I cut it in half. So I'm just going to look at one side of this right triangle. Just going to look at one side of it. Okay. Now, we know it's a right triangle. It would help if we knew some angles right there, because, well, we're not given a lot of information. We might be able to use what we know about special right triangles, because we don't have a second side to find the third side or anything like that. But if we can use special right triangles, then we're going to be good. So I'm going to find the the measure of that angle right there, because then I know I could cut that in half, and that would be the angle measure right here. So I'm going to find the interior angle of a hexagon. Remember that is 180 times n minus 2 divided by n. That goes back to investigation 3. Well, there are 6 sides, so if I plug in a 6 here, 180 times 4 divided by 6 gives me 120. This whole angle in there is 120, so that means that half of that would be 60 degrees. Okay, so this is a 60-90, which makes this a 30-degree angle. This is a 30-60-90 triangle. And the shortest side length is 5. To get the longest side length, we would double it, which would be the hypotenuse. 2 times 5 is 10. And then we'd multiply the smallest side length times the square root of 3. And look, that is our apothem. So we plug that in. Our apothem was 5 root 3. And we get 150 square root of 3 square centimeters. We could leave it like that, that is exact, or we could do 100 times the square root of 3, which comes out to be about 259.81 square centimeters. So we got the exact answer. We also have a rounded answer. Okay, we want to find the area of an equilateral triangle with an 18-inch sides. Well, we know so much about triangles, we can probably figure this out without thinking about an apothem. We can just look for the height instead of thinking about some central angle and things like that. Let's just find the actual height. Splitting the base to be 9 and 9. I know that an equilateral triangle has 60-degree angles, which makes this a 30-60-90 triangle. We take the length of the smallest side and multiply it by the square root of 3 to get the height right there. Notice how it's the shortest length doubled to get the hypotenuse times the square root of 3 to get the height in this case. So we have everything we need to find the area of an equilateral triangle. Area of a triangle is 1/2 base times height, which gives us 81 root 3. We could type that in the calculator. To get about 140.30 square inches. here it says the plot of land is in the shape of a regular octagon with 10-mile side lengths and Apothem about 12 miles. The plot needs to be divided into 8 equal parcels of land. What will the area of land be in each parcel? Well, first of all, we can find the area of the entire parcel of land. We know, because this is a regular octagon, 1/2 the Apothem times the perimeter. We're told the Apothem was 12 miles. The perimeter, if this is an octagon with 10-mile sides, would have a perimeter of 80. 1/2 12 times 80 gives us 480 square miles. But that's the entire plot of land. We want to divide it into 8 equal parcels, so we divide this by 8, which gives us 60 square miles per parcel.